viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhat College, University of Delhi. So presently we are going through our series of operating system concepts, and the module which we are presently studying is about the deadlocks. And we have already seen in our previous lecture that what actually a deadlock is, and what are the necessary conditions for occurrence of this deadlock. So I'll be taking a quick recap of these necessary conditions, and then I'll be moving to the agenda for today, which is basically about the resource allocation graphs. So deadlock is such a situation in we can say, let's say we are having two processes P1 and P2. So P1 is waiting for some of the resources to be released from the P2 and hence not able to move further. Similarly, P2 is also having some dependency on the P1 in terms of releasing some resources. P2 is also waiting for P1 to release some resources, and hence P2 is also not able to move, and they both are kind of in a deadlock situation. They both cannot proceed, and they are depending on each other for the release of resources. So this situation is known as deadlock. Now coming to what are the necessary conditions for deadlock, this we have already seen in detail in the last lecture. The four necessary conditions for occurrence of deadlock is the mutual exclusion, hold and wait, no preemption, and circular wait. So the four conditions are mutual exclusion, hold and wait, no preemption, and circular wait. And all these four conditions must hold for a deadlock to occur. Also, please note that these four conditions are not completely independent, as you have kind of some interdependency between these conditions. For example, we can say the circular wait condition implies the hold and wait condition, and they both are we can say dependent on each other, or circular hold and wait is dependent on circular wait. So these four conditions are not completely independent. Now coming to today's topic, which is about the resource allocation graph. So resource allocation graph, as you have got a sense about this structure with the name, that it is going to be a graph. It is a directed graph which is used in we can say detection of deadlock, or which is used for the description of deadlock. It works as a tool. So graph, as you know, is basically a data structure which consists of a set of vertices V and a set of edges E. Now here the vertices are basically partitioned into two different types of nodes. So the vertices here could be the processes which are requesting some resources, or the processes which are going on in the system, and vertices are also the resources which are available with the system. So P, which is the set of all the active processes, it could be any number of processes from P1, P2 till Pn, and also we have a resources set which is R1 to Rm, that is the set consisting of all the resources types in the system. So basically two types of vertices we can say in this resource allocation graph, P and R. P is for processes, R is for resources. Now if we can see this using a figure, so we have vertices which is having kind of two types. So one is the process vertex and another one is the resource vertex. Now within the resource vertex we also have kind of two types of categories. One is about the single instance and another one is about the multiple instance. So let us try to understand this. What is this single instance and multiple instance? So single instance resources are the resources whose multiple copies are not available. For example, in a single core system, let's say we talk about CPU. So CPU here is a single instance resource. But if we talk about an example of the resource which is of type multiple instance, we can have printers can have multiple instance, because in a system we can have multiple printers. And also we can have another example is the registers. So CPU is an example of single instance, while registers and printers are the examples of multiple instances. So registers in any case are multiple registers are available in the system, and printers can be multiple. So if one copy of the instance is available in the system, that is the single instance, and if multiple copies are available in the system, multiple instance resources we can say. So vertices basically of two types, process and resources. Resources again of two types, single instance and multiple instance. Now with this, let us come to the second part of resource allocation graph, which is about the edges. So as you are aware that any graph G is going to be a data structures which is dependent on two type of entities. One is the vertices and another one is the, we can say, edges. So vertices we have seen. So edges, if we kind of want to see, so the resource allocation graph which I am talking about here, as I have told you that it is a directed graph. So the edges will be of directed type. So there is going to be a directed edge between the vertices, or the edges will be of directed type between the vertices. So for example, if there is a directed edge from a process P to a resource type R, that is denoted by P. So the kind of we can say head of the vertex is head of the tail is P, head of the edge is P, and while tail is the R. So there is going to be the edge from P to R. This signifies that the process P has requested an instance of resource R, or any R, it could be R1 to Rm, for example. Let's say we take Rj. So a directed edge from a process to a resource indicates that the process has requested for the instance of resource and is currently waiting for the resource. Now there are basically, as I have told you, that there are two type of we can say resources. So two type of vertices. So one vertex of type process, another vertex of type resource. So when we say that there is a directed edge from process to resource, that means the process has requested it and it is currently waiting for that resource. Now the edge could be other way around. That means it will start from the resource and it will end to the process P. So basically a directed edge from the resource to a process is denoted by resource, then arrow operator or arrow symbol we can say, and then there is P. So it signifies that an instance of the resource type has been allocated to process P. So here, if we can say edge is from P to a process to resource, that means process is requesting that resource and has not been assigned yet. After assignment, when the resource is being assigned to the process P, then in that situation there will be a directed edge from a resource to the process. Now if the edge is from process to resource, that means the process is looking for the resource, or it kind of we can say requesting the resource is known as a request edge. And if there is an kind of directed edge which is from the resource to process, it is known as an assignment edge. So if resource has been given to the process, assignment edge is going to be from R1 to P or any R to P, and a directed edge from P to Rj is the request edge. That means the process has requested for the resource. So that is what the significance of resources here. That is what the significance of edges and the vertices. So with this, now we want to see how are we going to, as we have two type of vertices, one is process and another one is resources. What is the kind of representation mechanism if we talk about here in resource allocation graph? So if we want to represent the process, this will be represented by a circle, and if we want to represent a resource will be represented by a rectangle. Now in the previous lecture we have also seen that in terms of Deadlock, when we talk about the availability of resources, one very important point which we need to consider is about the instances or multiple copies of the resources. So here in the system, this is perfectly possible that a resource may have more than one instance. So now the question arises that how are we going to represent this more than one instance in the resource allocation graph. So what are we going to do? We are going to represent each such instance, of a resource whose multiple copies are available, each such instance as a dot within the rectangle. So circle is, for denoting the process, and rectangle is for denoting the resources. And if there are multiple instances of the resources, then we need to have, let's say one resource, for example printer is having 4 instances. So 4 dots will be, 4 dots will be put in within the rectangle of that particular resource. Now a resource is shown as assigned to the process if the tail of the arrow is attached to an instance to the resource and head is attached to a process. That we have already seen. So this is a kind of we can say a recap repetition. Resource is shown as assigned to a process if the tail of the arrow is attached to the instance of the resource and head is attached to the process. On the on the other hand, we can say on the contrary, a process is shown as waiting for the resource if the tail of an arrow is attached to the process while the head is pointing towards the resource. So that is what the significance of the directed edges, which are shown with the help of an we can say head and the tail on the other side. And a request edge points to only one rectangle. A rectangle here is the representation of the resource, whereas an assignment edge must also designate one of the dots in the rectangle. So if it is having multiple we can say instances where we need to assign one particular instance to a process, then in the assignment edge, in while drawing an assignment edge in the resource allocation graph, we need to be very, very careful that we need to designate one of the specific dots present in the rectangle to a particular process, and here these dots are representing instances of the resources. So here if you can see in the figure what type of edges we have. So vertices will be of 2 types that we have already seen, that is the process and the resources. On the similar lines, we have 2 types of edges. One is an assignment edge or assign edge, another one is the request edge. So assign edge goes from R1 to P, while the arrow pointer is towards the process, while if the process is requesting for the resource, it has not been assigned, so then the kind of arrow goes from P to R. So this is the significance of directions. We can say directions of the edges are going to show whether the resource has been requested or it has been already assigned. So 2 different things here. Similarly, in case of vertices, we have 2. One is process and another one is instance resources. Processes are represented by circle. Here also you can see in the figure that the processes are represented by circle while the rectangles are used to represent the resources. So now when a process is requesting a resource, this will be the kind of we can say figure which is available on the left side, that is it goes from process to resource, the edge goes from process to resource, and similarly on the other hand, if we can see resource is assigned to the process, then the arrow is pointing towards the process and goes from resource to process. Now coming to kind of how are we going to represent, or how are we going to use all these concepts of vertices and the directed edges from one direction to another or vice versa in construction of the resource allocation graph. When a process is requesting an instance of any resource type, then there is a request edge which must be inserted into the resource allocation graph. So, let us say we have a resource allocation graph, or we have depicted kind of the vertices. Now it's time to assign the edges. So, how are we going to assign the edges? When a process let us say P is requesting an instance of the resource type R of Ri, a request edge is inserted in the resource allocation graph. When this request can be fulfilled, now this request edge will be kind of changed to assignment edge, because now it's the time to fulfill the request. That means this request edge is going to be transformed into an assignment edge instantaneously, because the resource has been, we can say, kind of assigned to the process. And when the process no longer needs access to the resource, it releases the resource, and as a result this assignment edge is to be deleted. So, in our previous lectures we have seen kind of three phases of a normal operation of a particular kind of a process requesting the resource, which is kind of request, use, and then release. So, when the process is requesting and kind of request edge, a request edge is to be inserted. When the process is using, then there is going to be an assignment edge for the representation of that use phase, we can say. And when a process is no longer needs, that means it is kind of, we can say, releasing the resource. So, in case of a release of a resource, the assignment edge is to be deleted. So, in kind of introduction of request edge, conversion of request edge into the assignment edge, and then finally the deletion of the assignment edge. These are the we can say three basically phases, representation when we talk about this resource allocation graph. Now, let us try to take a complete we can say full-fledged example of this resource allocation graph. So, for this example, let us say we take 4 resources named as R1, R2, R3 and R4. So, there are only one instance of resource type R1, 2 instances of the resource type R2, 1 instance of the resource type R3 and 3 instances of the resource type R4. So, here we have 2 situations where there is a single instance of the resources and 2 situations where there are multiple instances of the resources. In case of R2 we have 2 instances, and in case of R4 we have 3 instances. So, apart from that we have 3 basically we can say processes here named as P1, P2 and P3. So, this P1, P2 and P3 when we are going to kind of represent in a resource allocation graph, what kind of we can say assignment edges or what kind of request edges are there. So, as far as the set of edges within this resource allocation graph is considered, we have these many edges which are shown in the shown on the screen. So, then there is a edge from P1 to R1, then there is an edge from P2 to R3, then there is an edge from R1 to P2, then from R2 to P2, next from R2 to P1 and from R3 to P3. Now, what is the significance of this? So, whenever we are having an edge from P1 to R1, that means that resource R1 is being requested by P1, and when there is an edge from R1 to let us say P2, that means which is the third edge here in the set of edges R1 to P2, that means we have seen that this resource R1 has already been allocated to P2. And how is this, this whole information is going to be, we can say completely represented or depicted in the form of a resource allocation graph. Let's have a look here. So this is the resource allocation graph of the scenario which we depicted, in which we have, four resources R1, R2, R3 and R4, and I have told you that R1 and R3 are having single instance, while the R2 and R4 are having multiple instance. So here you can see that in case of R2, within the rectangle which is representing R2, we have two dots. This signifies that there are two two instances of the resource type. In case of R4, we have three dots represented within the rectangle. That means we have three instances of R4. Now looking at this figure, we can say it is very clear that this resource R4 has not been asked by any of the process till this point. Neither it has been asked nor it has been assigned. So there is no edge starting from R4. Also there is no edge ending onto the R4. Now what is the situation of edges here? Let's see. There is an edge from P1 to R1. That means P1 is requesting R1, while this R1 is already allocated to P2, because there is an edge from R1 to P2, and please mind it that there is only one instance of R1 which has already been allocated to P2 according to this resource allocation graph. Now coming to the situation of R2. So R2, one of the instance of R2 is being allocated to P1 as it is indicated by the edge from R2 to P1. Similarly, the second instance of R2 is being allocated to P2, and now R2 is not having any of the instance free here in order to allocate that to any other process. Similarly, if we talk about we can say the process P2, this process P2 has we can say taken one of the instance of resource R2 and is also requesting for the resource R3, while this resource R3 with only one of its available instance, that particular instance has already been given to P3, which is indicated by an edge from R3 to P3. So here we can see that the information which we have seen in terms of what is the direction of edges, how are we going to represent the multiple instances of the resources, what will be the symbol for processes and what will be the symbol for resources, that whole information is being consolidated and compiled and used in order to represent this resource allocation graph. So this resource allocation graph is kind of depicting a very clear situation of the total resource state of the graph, that how many resources are available, what are the number of copies of those resources, which are the processes which are looking for which resource, and what are the resources that are being allocated to various processes. So this whole situation is being depicted with the help of this resource allocation graph. Now we can see that with these three processes we have four type of instances, and some processes are kind of waiting for the resources, and some processes are already in a we can say hold mode, or in a mode to hold the resources. So all this scenario is very clearly shown by this resource allocation graph. Now coming to this, that we have seen in this lecture we have seen this resource allocation graph. What is the significance of this resource allocation graph? As I have told you earlier, that this resource allocation graph is going to be a very important tool in helping us in we can say detection of deadlocks. So how this resource allocation graph is going to help us in detecting the deadlock in a system, or what will be the situation within the resource allocation graph, what is to be, we can say, what is to be monitored for the deadlock occurrences, that all we are going to see in our upcoming lectures. So here in this lecture we have seen what is resource allocation graph in detail, and here is a list of references which is being used for preparation of this lecture. Hope you have enjoyed the lecture. Thank you for a patient hearing.